Welcome back to section 2. So, under these conditions of low-grade or high-grade metamorphism, what kind of textures form? What can we see happening in these metamorphic rocks? So, when we're talking about heat and pressure, we're talking about something called stress. That's the name of it in geology. Kind of a force, we call it a stress. So when there's a stress being applied to a rock, in this case, pressure, stress can cause something called foliation. Foliation is a planar arrangement of textural features in a metamorphic rock. Essentially, taking kind of random stuff, and if you squish it, it kind of forms kind of flat layers. You know what? Let me pause here. Let me show you what I'm talking about. Hold on. Okay. Thank you for holding on. So, okay, imagine here's a nice igneous rock. You can see all the different crystals or a sedimentary rock made up of pieces of clast. Fun stuff, all right? So now I'm going to apply pressure, a stress, and let's see what happens to all these kind of crystals or clast. So if I apply a pressure, all right, they kind of flatten out and kind of line up. They kind of flatten out and line up. Right, they're more kind of linear now. I've applied a stress, pressure, to kind of squish everything, and that creates something called foliation. Foliation in metamorphic rocks gives us a layered or banded appearance. So that's one thing we look for, a good telltale sign of a metamorphic rock. This is a type of igneous rock called, looks like granodiorite. You can see the black, white, clear pieces, but all kind of, more roundish crystal grains. You apply a pressure to that, stress, and all of those pieces get, squished and elongated, and you create this foliation. It gives it a layered or banded appearance. You can also get veins. So metamorphism is often affected by the presence of open fluid-filled spaces called pores. Oftentimes, and these are just small little spaces in between the individual pieces of a rock, microscopic, sometimes even submicroscopic. As pressure increases on a rock, the pore spaces decrease, the fluid is driven out, sometimes creating these veins as this material is kind of squirted through everywhere. For instance, quartz veins in a rock. So these quartz veins in a rock are created when rocks are squeezed so much that this quartz material kind of squirts through any breaks or cracks in the rock. So that's another good indication of metamorphic rocks. We're looking for layers or banded or layers or lines or sometimes veins. So what type of textures do we see that exhibit this kind of stuff? Well, there's something called slaty cleavage, schistosity, mineral banding, and megmatic texture. So slaty cleavage is a parallel foliation, a layering of fine-grained platy minerals in a direction perpendicular to the maximum stress. So for instance, this example here, you can kind of see the layers of these rocks. You can kind of see the flaky layers in these rocks. So there was a stress applied down and up to this rock to make it kind of layered in this direction, this parallel foliation layering. This is typical texture in a low-grade metamorphic rock. Some low-grade metamorphic rocks that look like this include slate and phyllite. So you take a metamorphic rock, some heat and some pressure, but under low-grade conditions, and you will turn it into a slate or a phyllite. So here's an outcrop of slate. Again, you can see that foliation, was layering. Slate historically has been used, since you can break it into these flat kind of layers, since it has that foliation, you can break them into these flat layering. Was used a lot in Europe for tiles on the top of a roof to create a waterproof roof, a hard roof. Or if any of you play billiards, pool, slate, large slab of slate is what makes up the kind of the table part of some of your higher quality pool tables. It's slate because it can be perfect. It can be smoothed perfectly due to foliation. It doesn't bend or warp like if you had a wood table. If you have a cheap pool table, this is wood, but on the fancier, more expensive one, it's slate. That's what also makes pool tables so darn heavy. So that's slate. Both slate and phyllite have a slaty cleavage. Then you get a type of texture called schistosity. Ooh, this is a fun one. Again, layering due to parallel arrangements of platy minerals, such as muscovite and biotite. These one direction of cleavage flat, minerals. Other minerals that might be present in rocks that have a schistosity texture are quartz, garnets, which are these kind of gemstones embedded in this rock, and another mineral called starolite. This is an intermediate grade metamorphism texture, so somewhere between low and high. A good example of a rock type that exhibits schistosity is the metamorphic rock schist. Slate has slaty cleavage. Schist exhibits schistosity. Go figure. This is a very cool rock. One of my favorites. I love metamorphic rocks. It's really shiny, but you can also kind of see the layering in it. You get these garnets, which are gems. That's a cool rock. So here's an outcrop of schist. Again, you can see that foliation, that layering to it. It's hard to see the shininess and the possible gems in there, but it's pretty cool to look at once you kind of clean it off and take a look. Oftentimes it's very, very shiny. And then you apply even more heat and more pressure, and you can get into mineral banding. Again, the layering in which bands or lenses of granular materials, for instance, quartz, which is the white material, feldspars, which can be the black material, they alternate with bands or lenses in which platy material, like muscovite and biotite, minerals are predominant. So this is, when you see these kind of mineral bands here, you're looking at high-grade metamorphism. A typical metamorphic rock called gneiss, is a good example of that. So gneiss exhibits a mineral banding texture. For instance, it looks like I got some gneiss right in here. If you look at it, you can see the bands of minerals in this rock. So it's some gneiss. That's how it's pronounced. Not genus, not Genesis, gneiss. So here's some outcrop of gneiss. Oftentimes you see it kind of white and black, sometimes a little pink thrown in there as well. Oftentimes this is when you take granite, you apply some heat and pressure, you can turn it into gneiss under high-grade metamorphism. And then you get into something called magmatic texture. This is a metamorphic texture. Schistosity or mineral banding are intermixed with igneous textures, so coarse-grained igneous rocks. So this is the transition from high-grade metamorphism into melting into the range of igneous rock. So you're not getting a full melt, but you have high-grade metamorphic material kind of in a rock with some material that has been melted and then now cooled. So you get a mixture of both metamorphic and igneous rocks. We're kind of, again, leaving the realm of high-grade metamorphism, getting down into the realm of igneous rock, but the rock has not completely melted yet. Then if it did and it cooled and crystallized, that would be igneous. So this is like a half and half, and we call it a magmatic texture. A good type of metamorphic rock that exhibits magmatic texture is migmatite. Migmatite. Go figure. Sometimes you'll see some kind of wavy layering. Sometimes it's really wavy layering. This is a migmatic outcrop up in, it's my foot, up in the Estrella Mountains. I was hiking the Estrella Mountains. You can see this wavy texture. You see foliation, the layering, mineral banding, I should say, excuse me, but also this wavy texture. So that's a little bit more heat, a little bit more pressure. Things started to melt, not all the way. This is a migmatite. So what we'll do, and now that we've talked about the textures of metamorphic rocks and some examples, we'll stop here. When we come back, we'll talk about examples, a little bit more about metamorphic rocks. I'll see you back here in just a minute.